Alright boys, today our lesson is on recurring decimals, and we're going to investigate how these work. Now the one that we talked about the other day was thirds or ninths as well, so we said that a third was 0.333 and so on, and the notation we used for that was 0.3 recurring. And just as an idea, let's check how this happens. If you already know this, let's just check it out anyway. We're doing a division, so it's how many times does 3 go into 1. Okay, so we'll set it up as a division, and we know it's not going to go in equally, so put some zeros there. That's our decimal place. So how many times does 3 go into 1? Well, it doesn't. How many times does 3 go into 10? It goes 3 times with 1 left over, 3 times with 1 left over, and that'll keep happening. And then our notation, of course, here we use is 0.3 recurring, which means that 3 will keep going infinitely. Now we looked at this for ninths as well, and we said that 1/9 is 0.1 recurring, and 2/9 was 0.2 recurring, and 3/9, which is a third, is 0.3 recurring. So that's a nice one to deal with there. Now let's have a look if we have some other numbers that are recurring decimals. Let's look at an 11th. Okay, well that's going to be a recurring decimal, but let's check out what it will be. So if I'm trying to fit 11 into 1, we know we're going to need some zeros. Let's see, well how many times does 11 go into 1? It does not. Okay, so how many times does 11 go into 10? Okay, well it still doesn't go in. 11 goes into 100 now, because I'm looking at those 3 numbers. Well, that goes in 9 times with 1 remaining. Okay, well again, how many times does 11 go into that 10 there? Well, it doesn't. But how many times does it go into the 100? Well, it goes in 9 times with 1 remaining. And I hope you see that this pattern is going to keep happening. If I do it one more time just to confirm, and I can keep adding zeros infinitely, by the way, because it's after the decimal place. Well, it's going to go into that 100 9 times with 1 left over, and you'll see the pattern continues. So this time we've actually got in our pattern these 2 numbers are recurring. Okay, recurring or repeating. So what we would then say is that 1/11 is going to be equal to 0.09, and because it's 2 numbers repeating, we put 2 dots. Okay, we put 2 dots over the top, and all that means is that both numbers repeat, and infinitely. Okay, they repeat infinitely in the same pattern, and if you check this on your calculator, and I've got mine sitting in front of me right here, it says 0.090909 and so on, and it ends with a 1. And the only reason that is, it doesn't mean the pattern stopped, it just means that your calculator has run out of space, and it rounds it, and it rounds one of the 9s up to a 1. So your calculator might tell you it stops, but in fact it doesn't. Let's look at one more. So this time we're going to look at a 99th. Well, straight away we're going to split that, and we're going to see what it means. Well, a 99th means that I have 1/9 times 1/11. Okay, well that means that if I've got it's a product of a 9th and an 11th, we know that's 0.1 recurring, and that's 0.09 recurring, both numbers recurring. It's going to be some product of those 2. Right, well let's check out what it ends up being. Okay, well we could do it as a division again. We could say how many times does 99 go into 1. We know we're going to need lots of zeros this time. Okay, straight away I know it doesn't go in. How many times does it go into 10? Well again it doesn't. How many times does it go into 100? Well just once this time, and with 1 remaining. And how many times does it go into 10? Well it doesn't. 100, 1, with 1 remaining. Okay, do we see a pattern there, boys? I hope we're starting to see, I've put in 1 too many zeros, I'm sorry. I hope we're starting to see a pattern that in fact 1/99 is 0.01 recurring, where both numbers recur. Now we can take this and we can say that if we have any fraction that's over 99, we can write it as a recurring decimal straight away. So what that means is if I've got something like, let's take 63 over 99. Well, let's look, can we simplify it? In fact, let's not use 63, we might use 64. 64 over 99. Now, I've intentionally picked them because they don't simplify. There's no common factor there. And what that will be is, it's just whatever two numbers we have in our numerator are our recurring pattern. That's because what we've really got is 1 over 99 times 64, and that ends up being our 64 times 0.01, which is, of course, if we look at it, 0.64 recurring. Okay? Let's look at 11ths. Okay, so if I've got, we know that our 1 over 11 is 0.09 recurring. So what if I have 5 over 11? Okay, well that's just 5 times 0.09 recurring, which is going to be, what? 5 nines are 45, so it's 0.45 recurring. And we could check this using a division. We could go and say 5. How many times does 11 go into 5? And test it this way. Well, how many times does 11 go into 5? It doesn't. 50, it goes in, what, 4 times with 6 remaining. And it goes in 5 times with 5 remaining. It goes in 4 times, and so on. You'll see the pattern keeps happening. We could test it with a division. All these ones we can actually just work out and know as well. So if we know an 11th, a 99th, and a 9th, as we said, we're in a good place. So we've recognised that a 9th is 0.1 recurring, an 11th is 0.09 recurring, and then as a result of those two, 1 over 99 is 0.01 recurring. Okay, sorry about this 9 down the bottom, just making life interesting. Alright, good stuff, boys. We'll make a summary of these. Can we make sure we've got those written down into our theory book as well? I'll give you some notes too. Thanks, boys.